loud clicking noise and low-frequency hum heard when turning off the high bay fixtures are likely due to a combination of factors involving the electrical system and the building's acoustics. Firstly, consider electrical arcing. As lighting contactors open to turn off circuits, a momentary electrical arc can occur between the contacts. This arc generates a spark and a loud clicking sound, particularly if the contacts are dirty or worn. The low-frequency hum might stem from the vibration of the contacts as they open and close. Secondly is the inductive load effect. High bay fixtures often use fluorescent or LED lighting containing inductive components such as ballasts or drivers. When an inductive load shuts off, the magnetic field around it collapses. This induces a high voltage spike in the opposite direction. The voltage spike can cause the contacts in the lighting contactors to chatter, thus creating more clicking noises. Thirdly, building acoustics play a role. A large, empty gymnasium serves as a resonant chamber, amplifying sounds produced by the electrical system. Hard surfaces like walls, floors, and ceilings reflect sound waves, creating a loud and reverberant effect. The absence of other noises such as people talking or machinery running makes the clicking and humming more noticeable. Technically, electricity itself doesn't create sound. Sound is a mechanical vibration that moves through a medium like air. However, electrical devices can generate vibrations converted into sound. For instance, the opening and closing of electrical contacts, vibration of inductive loads, and magnetic fields created by electrical currents can all produce audible noises. In conclusion, the loud clicking noise and low-frequency hum are most likely a result of electrical arcing, inductive load effects, and the building's acoustics. These factors work together to amplify sounds from the electrical system, creating a noticeable and loud effect when the lights are turned off. When dealing with electrical systems, safety is paramount. Always ensure circuits are properly energized before performing any maintenance or inspection. If you are not qualified to work on electrical systems, contact a licensed electrician. Let's delve deeper into electrical arcing. Arcing occurs when electricity jumps across a gap in a circuit, creating a plasma discharge. This discharge generates heat, light, and sound. In the context of lighting contactors, arcing is most likely to happen when the contacts are separating to break the circuit. The rapid separation of the contacts can cause a brief but intense arc, resulting in the clicking noise you hear. Factors that worsen arcing include dirty or corroded contacts, loose connections, and high voltage levels. Over time, repeated arcing can damage the contacts, leading to increased resistance and heat generation. This can ultimately result in premature failure of the contactor. Now let's explore inductive loads. Inductive loads store energy in a magnetic field when current flows through them. Examples of inductive loads include motors, transformers, and ballasts used in fluorescent lighting. When the current to an inductive load is suddenly interrupted, the magnetic field collapses rapidly. This collapse induces a voltage spike that can be several times higher than the normal operating voltage. The magnitude of the voltage spike depends on the inductance of the load and the rate of change of current. To mitigate voltage spikes, surge suppressors or snubbers are often used in conjunction with inductive loads. These devices absorb the excess energy and prevent it from damaging other components in the circuit. The building's acoustics also play a significant role in amplifying the clicking noise. A large, reverberant space like a gymnasium has a long reverberation time. This means that sound waves bounce around the room for an extended period before dissipating. The hard surfaces in the gymnasium, such as the walls, floor, and ceiling, reflect sound waves efficiently, further increasing the reverberation time. The combination of a large volume and reflective surfaces creates an environment where even small sounds can be amplified significantly. This is why the clicking noise from the lighting contactors sounds so loud and thunderous. To reduce the impact of building acoustics on noise levels, sound-absorbing materials can be used. These materials, such as acoustic panels, curtains, and carpets, absorb sound waves and reduce reverberation. The strategic placement of sound-absorbing materials can significantly improve the acoustic environment of a gymnasium. Now let's further examine the electrical aspect, specifically high bay lighting systems. High bay lighting fixtures are typically used in large spaces with high ceilings, such as gymnasiums, warehouses, and factories. These fixtures provide high light output and are designed to distribute light evenly over a large area. High bay fixtures can use various types of lamps, including fluorescent, metal halide, and LED. Fluorescent lamps are energy efficient and have a long lifespan, but they require ballast to regulate the current. Metal halide lamps produce a bright, white light, but they have a shorter lifespan and require a warm-up period. LED lamps are the most energy efficient and have the longest lifespan, but they can be more expensive than other types of lamps. The choice of lamp type depends on the specific requirements of the application, such as lighting level, energy efficiency, and maintenance costs. When troubleshooting electrical noise issues, it's important to consider all potential sources of noise. This includes not only the lighting contactors and high bay fixtures but also other electrical equipment in the building. Motors, transformers, and electronic devices can all generate electrical noise that can propagate through the electrical system and cause interference with other equipment. To identify the source of electrical noise, a spectrum analyzer can be used. This instrument measures the amplitude of electrical signals at different frequencies, allowing you to pinpoint the frequency range where the noise is most prominent. Once the source of the noise has been identified, appropriate mitigation measures can be taken. These measures may include installing filters, shielding cables, and grounding equipment properly. Now let's dive into the operation of lighting contactors. Lighting contactors are electromechanical switches used to control lighting circuits. They are typically used in large buildings where there are many lighting fixtures that need to be switched on and off simultaneously. Lighting contactors consist of a coil, contacts, and a mechanism for opening and closing the contacts. When the coil is energized, it creates a magnetic field that attracts the contacts, closing the circuit and turning on the lights. When the coil is de-energized, the magnetic field collapses, and the contacts open, turning off the lights. Lighting contactors are available in various sizes and configurations to accommodate different voltage and current ratings. They are typically mounted in electrical panels and wired to the lighting circuits. Regular inspection and maintenance of lighting contactors are essential to ensure their proper operation. This includes checking the contacts for wear and corrosion, tightening loose connections, and cleaning the contactor enclosure. A faulty lighting contactor can cause flickering lights, trip circuit breakers, and even electrical fires. So, let's investigate the effects of widespread power outages. Widespread power outages can occur due to various reasons such as severe weather, equipment failures, and grid instability. During a power outage, all electrical devices in the affected area will stop working, including lights, appliances, and computers. The sudden loss of power can be disorienting and even frightening, especially at night. In the absence of artificial light, the darkness can seem overwhelming. The silence that follows a power outage can also be unsettling. With all the usual background noises gone, you may become more aware of subtle sounds that you normally wouldn't notice. These sounds may include the ticking of a clock, the rustling of leaves outside, or the creaking of the house. The perception of silence can be amplified by the contrast with the noise that was present before the power outage. The sudden transition from a noisy environment to a silent environment can make the silence seem even louder. Power outages can also have significant economic and social consequences. Businesses may be forced to close, disrupting production and commerce. Hospitals and emergency services may be strained by the increased demand for their services. And individuals may be left without essential services such as heating, cooling, and water. To prepare for power outages, it's important to have a backup plan in place. This may include having a generator, storing food and water, and knowing how to operate emergency equipment. You should also familiarize yourself with the emergency procedures in your area and know how to contact emergency services if needed. Understanding these aspects will help to diagnose and address the underlying causes of the sounds. Now, let's look at practical solutions for mitigating these noises in a gymnasium setting. Firstly, ensure proper maintenance of lighting contactors. Regularly inspect and clean the contacts to minimize arcing. Replace worn or damaged contactors promptly. Secondly, install surge suppressors. Protect the lighting contactors from voltage spikes caused by inductive loads. Choose surge suppressors with appropriate voltage and current ratings. Thirdly, consider using electronic ballast or LED drivers with soft start capabilities. These devices reduce the inrush current and voltage spikes when the lights are turned on or off. Fourthly, improve the acoustics of the gymnasium. Install sound-absorbing materials such as acoustic panels, curtains, and carpets to reduce reverberation. Strategically place these materials to maximize their effectiveness. Fifthly, isolate the lighting contactors from the building structure. Mount the contactors on vibration damping pads to reduce the transmission of noise and vibration. Sixthly, review grounding practices. Ensure that all electrical equipment is properly grounded to minimize electrical noise. Verify that the grounding system meets the requirements of the National Electrical Code Section 250. Seventhly, consider the placement of the lighting contactors. If possible, locate the contactors in a separate room or enclosure to isolate the noise from the gymnasium. Eighthly, implement a phase shutdown of the lighting circuits. Instead of turning off all the lights simultaneously, stagger the shutdown of the circuits to reduce the overall noise level. Ninthly, consider the use of solid-state relays. Solid-state relays offer silent operation compared to electromechanical contactors. These are a more expensive option, but provide enhanced performance. Tenthly, consult with an electrical engineer or acoustical consultant. Seek expert advice to identify the best solutions for mitigating the noise in your specific situation. These are just a few examples of the many methods that can be used to mitigate the noises associated with high bay lighting systems in gymnasiums. While carefully considering the various factors involved and implementing appropriate solutions, it's possible to create a quieter and more comfortable environment. Let's discuss the relevance of the National Electrical Code, or NEC. The NEC is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is widely adopted in the United States and other countries. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect changes in technology and industry practices. Compliance with the NEC is essential for ensuring the safety of electrical installations. Failure to comply with the NEC can result in electrical fires, injuries, and even death. The NEC provides specific requirements for the installation of lighting contactors. These requirements include proper wiring methods, overcurrent protection, and grounding. The NEC also requires that lighting contactors be listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. A listing ensures that the contactor has been tested and found to meet safety standards. The NEC addresses the issue of electrical noise. Section 300.3 F governs the installation of conductors to minimize inductive heating. Although it does not directly address lighting contactors, it provides general guidance on how to minimize electrical noise. Following the requirements of the NEC is crucial for ensuring the safe and reliable operation of lighting contactors. It also helps to minimize the risk of electrical noise and interference. Let's consider the safety measures. Safety is the top priority when working with electrical systems. Electrical shock can cause serious injuries and even death. It's essential to follow all safety precautions to minimize the risk of electrical shock. Always de-energize circuits before working on them. Use appropriate personal protective equipment or PPE, such as rubber gloves, safety glasses, and insulated tools. Never work on electrical equipment in wet or damp conditions. Be aware of the potential hazards of electricity and take steps to avoid them. If you are not qualified to work on electrical systems, contact a licensed electrician. Working with electricity can be dangerous, and it's best to leave it to the professionals. When troubleshooting electrical noise issues, it's important to follow a systematic approach. Start by identifying the source of the noise. This may involve using a spectrum analyzer or other diagnostic tools. Once the source of the noise has been identified, take steps to mitigate it. This may involve installing filters, shielding cables, or grounding equipment properly. Always verify that your solutions are effective by measuring the noise level before and after implementing the mitigation measures. If you are unsure about any aspect of electrical safety or troubleshooting, consult with a qualified electrician or electrical engineer. They can provide expert guidance and help you to resolve your electrical issue safely and effectively. Let's discuss the practical implications for the gymnasium users. The loud clicking noise and low-frequency hum can be disruptive to activities in the gymnasium. It can interfere with sporting events, performances, and other gatherings. Reducing the noise level can improve the overall experience for users of the gymnasium. This can be achieved by implementing the mitigation measures discussed above, such as installing sound-absorbing materials and replacing noisy lighting contactors. A quieter gymnasium can create a more pleasant and comfortable environment for athletes, performers, and spectators. This can lead to increased participation in activities and greater enjoyment of the space. Now let's address the energy efficiency aspect. Replacing old lighting fixtures with new, energy-efficient LED fixtures can save a significant amount of energy. LED fixtures consume much less energy than traditional fluorescent or metal halide fixtures. They also have a longer lifespan, which reduces maintenance costs. In addition to saving energy, LED fixtures can also improve the quality of light in the gymnasium. They provide a brighter, more uniform light that can enhance visibility and reduce glare. When selecting LED fixtures, it's important to consider the color temperature and color rendering index. The color temperature affects the appearance of the light, while the color rendering index affects how accurately colors are perceived. For gymnasiums, a color temperature of around 4000 Kelvin and a color rendering index of 80 or higher is generally recommended. Installing energy-efficient LED fixtures can not only save money on energy bills but also improve the overall quality of the lighting in the gymnasium. And to expand even more, let's talk about preventative maintenance. Regular maintenance of the lighting system can help to prevent problems and extend the lifespan of the equipment. This includes inspecting the lighting fixtures, cleaning the lenses, and replacing any damaged components. It's also important to check the wiring and connections to ensure that they are in good condition. Loose or corroded connections can cause voltage drops and overheating, which can damage the equipment. A well-maintained lighting system will operate more efficiently and reliably, reducing the risk of costly repairs and downtime. A proactive approach to maintenance can save time and money in the long run. And let's talk about the role of a qualified electrician. A qualified electrician has the knowledge, skills, and experience to safely and effectively install, maintain, and repair electrical systems. They are trained to identify and address potential hazards, ensuring that electrical work is done in accordance with the NEC and other applicable codes. Hiring a qualified electrician is essential for ensuring the safety and reliability of electrical installations. They can provide expert advice and guidance on all aspects of electrical work, from selecting the right equipment to troubleshooting problems. A qualified electrician can also help you to save money by identifying energy-efficient solutions and preventing costly repairs. When choosing an electrician, be sure to check their credentials and experience. Verify that they are licensed and insured. Ask for references and check their reputation online. A reputable electrician will be happy to provide you with this information. Finally, consider future upgrades. As technology advances, new and improved lighting solutions will continue to emerge. It's important to stay informed about these developments and consider future upgrades to your lighting system. This may involve replacing old fixtures with newer LED fixtures, installing smart lighting controls, or integrating the lighting system with other building systems. Future upgrades can improve the energy efficiency, performance, and functionality of your lighting system. They can also enhance the overall environment of the gymnasium. By planning for future upgrades, you can ensure that your lighting system remains state-of-the-art and meets the evolving needs of your facility.